In this example, we are given two polynomials and we need to prove that the first polynomial is big O of the second polynomial using ad hoc calculations. This example is a little bit different than previous examples on polynomials. Previously, we were asked to prove a polynomial was big O of its dominant term. By comparing the terms of these two polynomials, notice that the first polynomial has a term with x raised to power 3, but the second polynomial does not have such term. Also, the second polynomial has a term with x raised to power 2, but the first polynomial does not have such term. So we need to find an intermediate function that shares the same terms as g of x. So let us write it down. We need to find a polynomial, and we are going to call it h of x, such that f of x is less than or equal to this polynomial h of x and less than or equal to c multiplied by g of x. At the same time, that it should have this polynomial, which is h of x, should have the same terms as g of x. Not necessarily with the same coefficients, but with the same terms with the power of x. So how to find this polynomial? We will start with f of x, which is equal to 2x raised to power 4 plus 7x raised to power 3 minus 3x plus 4. By comparing the two functions or the two polynomials, now I don't have x raised to power 3 and g of x. So how to get rid of this term? We will replace 7x raised to power 3 by its dominant term, and it will disappear from this equation. So it means like we will combine it with the dominant term. So this is the first step. But when you combine it with the dominant term, so we will just copy 2x raised to power 4, which is the dominant term. We copy it, and we will replace this term by the dominant term. So it will be plus 7x raised to power 4. Now, this polynomial has the term 5x squared, but in here we don't have 5x raised to power 2. So we can introduce it, because since it is positive, so we can simply add it, 5x raised to power 2, and still this equation is less than this equation because we assume that this term is in here but multiplied by 0. So we assume we have 0x raised to power 2, which is less than 5x squared. Also, this negative number, we will convert it into positive because in g of x we have it positive. So minus 3x, we will simply replace it by plus 3 of x. And again, since minus 3x is less than 3x, so this polynomial is still less than or equal to this polynomial. And the constant, we will just keep it, which is plus 4. Simplify this equation, last equation. So it will be 9x raised to power 4 plus 5x squared plus 3x plus 4. And we will call this function as h of x. H of x is equal to 9x raised to power 4 plus 5x squared plus 3x plus 4. In the next step, we need to find a value for c as a constant, such that h of x is less than or equal to c multiplied by g of x. So let us write the equation for g of x. It is a 3x raised to power 4 plus 5x squared plus 6x plus 2. Now, to make this polynomial less than or equal to this polynomial, we need to find a value of c. So let us assume a value of c, and then we can check whether h of x will be less than or equal to the resulted polynomial. And I'm going to write it in blue color as a draft. Let's say if c is equal to 1. So what we are going to have in this equation, it will be 3x raised to power 4 plus 5x squared plus 6x plus 2. Now by comparing h of x with the resulted polynomial term by term, 9x raised to power 4 is not less than 3x raised to power 4. So I cannot make this polynomial less than or equal to this polynomial when c is equal to 1. So this will not work. Let us try another value of c. Let us try 2. So when you try 2, you will have 2 multiplied by this polynomial. It will be 6x raised to power 4 plus 10x squared plus 12x plus 4. Again, by comparing this polynomial with this polynomial, 9x raised to power 4 is not less than or equal to 6x raised to power 4. So we will try the next value of c, and maybe you can come directly to c equal to 3 by comparing this term with this term. And you need to make, when you multiply this term by c, you need to make the term greater than or equal to 9. So the candidate value of c will be 3, because when you multiply it by 3, you are going to get 9. So when c is equal to 3, you will have 9x raised to power 4 plus 15x squared plus 18x plus 6. And again, this will not work, but for this one, it will work. Why it will work? 9x raised to power 4 is less than or equal to 9x raised to power 4. 5 is less than 15, and 3 less than 18, and 4 less than 6. Remember, h of x and g of x share the same terms, with the same power of x. So now this is a draft. So we know that this is now our target polynomial. So we can say the following: 9x raised to power 4 plus 5x raised to power 2. And maybe I should start with the following by saying that h of x, which is equal to this, plus 3x plus 4 is less than or equal to, I will replace 9x raised to power 4 by 9x raised to power 4, same term. And I will replace 5x squared by 15x squared. And we will replace 3x by 18x. And we will replace finally 4, we will replace it by 6. So every term in h of x is smaller than every corresponding term on this polynomial. Now here in this polynomial, the last polynomial, you take 3 common. So you will have 3x raised to power 4 plus 5x raised to power 2 plus 6x plus 2, and this is equal to 3 multiplied by g of x. So here we can say that h of x is less than or equal to 3 multiplied by g of x. And remember that in the beginning, f of x was less than or equal to h of x. So therefore, we say that f of x less than or equal to 3 times g of x. And if we assume that c is equal to 3 and k is equal to 1, this will prove that f of x belongs to big O of g of x. A remark before we end up the solution of this example: these steps that we have followed will work only if the polynomial g of x has all positive coefficients. If we have some of the terms with negative coefficients, then the steps that we have done in this example might not work. So we need another ad hoc calculations, another type of steps, tricks to prove that f of x belongs to g of x.